Hi Hugh, just imagine we are in a deep sea and suddenly a torpedo is running to us. What should we do? Why submarine? Why it is easy? Sinking to the bottom? I want a permanent solution. Whoa. Now let's take a look at how Robot Pew responds to coming torpedoes. I use my fist to simulate torpedoes. You can find the teaching material in RoboGene website, Story of Pew Book 3 Growth, and there's under Learn JavaScript with Robot Pew. There's one section called Lieutenant Pew, the Sonar Operators. And in this lesson, we basically going to train you how to write a really complex like a logic decision engine, use sensors and use preconditions. First of all, let's take a look at the what the logic looks like in block programming. In a microbit, the block looks like it's an if-else statement, and this rectangle, this hexagon here is mainly the judgment, is the Boolean operations, and to in computers and robots, they make a lot of decisions. And in our this Sonar cases, we just need to make if-else statement and calculate the torpedo speed and make multiple selections to say whether the coming object is a torpedo or not. If when the program make decision that that's a torpedo, then robot Pew will jump and running away. Then that's the logic. If you want to learn all the math behind those logic operations, I would strongly recommend you follow the link in the tutorials to go through those like a truth table and some math theory behind it. It will help you to write really clean code. And let's go back to the program. Say the program we're going to use is this one. Basically, what we're going to do we are going to first do the detection of the sonar distance. Then we calculate the closing speed of objects, and then we calculate the time to collision. Time to collision is estimate how soon the torpedo will hit robot Pew, and when the multiple conditions met, robot Pew will say based on different conditions, robot Pew will say either send warning message, say torpedo is coming, and contact in X seconds. If the contact is imminent, robot Pew will jump and to running away from it. If it detects its torpedo is running, torpedo miss robot Pew, then robot Pew will stop jumping and go back to the normal walking style. So then let's take a look at the code. We click the edit, then we can go to the code, and it is the block programming, and this is JavaScript. It's easier at here. As you can see, first you need to define those variables, and in those first variable it is how soon you played what's the beeping interval, And the second one, it is second variable, it is the beep pitch frequency. And in order to calculate the torpedo speed, you need to memorize what's the last distance of the torpedo. And you also need to uh, remember what time you make an observation. So then based on the distance you see this time and the last time, you can calculate torpedo speed. Say, and at here, as you can see at here, we need a two forever loop. The reason we put the two forever loop, it is we don't want the measurements block the movement, and we don't want the movement block the measurements. So in this case, the robot P will be more responsive to the coming torpedoes. The basic idea is robot have a different mode. In a regular mode, robot P just walk with a speed which is mapped between the speed was mapped from the sonar distance to the speed. Say that means when the object is getting closer, it will walk slower. When there's no obstacles, it will walk fast. And the other thing, the second mode is a rest. When the torpedo is imminent, then they will go to the rest mode and just got prepared. When the torpedo is really close and about to hit robot P, you will go to mode 3, and the robot P will start to jump. Try to run away from the torpedo. So basically that's the if-else logic. You basically, this is the decision engine for robot P to take action, and this is the forever loop for measurements. As you can see, for every time you make measurements, you have to record the measurement time. So this is this variable saved to the milliseconds, because we remember the time in milliseconds. Then right after that, you get the distance from the sonar sensor. Then you calculate you calculate the delta time. Say what's the observation time interval. Then you can calculate the speed by last distance minus the current distance divided by the time interval. So at here, we basically just plot out how soon the distance it is. Then you can see that how far away the robot P how far away the torpedo in the microbeep LED. Say then right after that, it is what you learn from the previous tutorial about how to map the distance into beeping frequency and beeping interval. Then you play the tune here. So, and this it is a place the code makes decision. Say if the closing speed it is really fast, so it will start to calculate the time. TTC is the time to collision, and then we make decision. Really complex logic here. So you have to when you implement your own version of the Sonar operator, so you can apply a better logic here. Basically, here it is. If the closing speed is really fast, that means it's a torpedo, and the robot will raise the voice and set the mode into 3, and in a LED panel, it will show a skeleton, and it will send out a broadcast message to the rest of the robot, say torpedo is coming, and then it will say torpedo warning. Then you will say what's the torpedo speed, and we'll play the melody. Then say if it is just regular block, and robot P will basically say if it is not torpedo and it's close to some wall or something, the robot P will go to rest mode. It just say danger and stop. And in the rest of the mode, and everything it just looks okay, always the torpedo is too far away, robot P will just say, oh, just walk around, and yeah. If nothing happen and robot P we basically just do whatever it wants. Basically it's a mode 0. So what is mode 0? Let's go back, take a look at the mode 0. It is basically just walk around. Okay, so, and do remember, you have every time you have to memorize what's the last distance or what's the last timestamp, so you can calculate the torpedo speed. Hi Pew, are you aware of your torpedo actions?
Robot gyms.